In computer graphics, I take a lot of inspiration from video games. And I especially love a game called Rain World. I would highly recommend it to anyone interested in adventure survival games. It's a game where you're tossed into an ecosystem overrun by procedurally powered creatures. These creatures are the most impressive procedural NPCs I've seen. It's super complicated, and there aren't any games quite like it. These NPCs have tons of documentation on their advanced mechanics, but they aren't the main focus of this procedural shader video. The focus of the video is actually down here in the bottom left. It's a UI feature in Rain World that provides information to the player. The game mechanics are unimportant for this video, since we only want to emulate the moving parts of this user interface. After taking a picture and popping it into Blender, we divide this interface component into 3 basic segments. First is a series of pixelated circles, which we can make pretty quickly using some simple nodes. And before pixelating the shader, we should just focus on making the general shape. So, to make 2 circles, we use an absolute node, subtract, and add a length node at the end. But we can split these coordinates down the middle by adding another absolute node and then subtracting, which would give us 4 points with a value of 0 in our coordinates. Now we can add a length node and compare to make a ring around these dots. To space these circles evenly, we take half our initial subtraction and add that to the second. Here's a simple shader that has just one scaling input, with the circles spaced out evenly. And once finished, we can place it behind the reference picture and reposition it if necessary. Now is a good time to implement a pixelation effect, which may seem complicated, but it's as simple as flooring both axes by the same value. The method I used involved this snap node, but you can use a Voronoi vector output to get the same effect if you prefer. I plugged a single value into the snap node and decreased it. The smaller the value, the more quote-unquote pixels we have. After achieving a similar resolution to the reference, I tweaked the result to avoid a few pixels jutting out from the main shape. After that, I took our original gradient and made smaller circles within these rings. I'll keyframe this threshold slider for future animations. Following my reference, I duplicated this ring system and shifted it to the right. In shaders, I recreated this little animation. I did it by flooring a horizontal gradient until it aligned with the 4 circles. I used the reference image as a blockout for the circle's position. After some tweaking, we can use this floored gradient to reveal the circles. I used a map range node to change the circle's size back to normal. And after adding the frame value to a subtract node, we get this effect. We can actually control the time it takes for each circle to inflate by changing this multiply slider. Moving on to this large circle, it's mostly the same as the circles from earlier. But the large one has way more pixels than the other rings. For this, we'll make a separate snap node and give it another value. Let's say half the previous snap's value. In this case, that would be 0.01. This means it has twice the density than the other rings. Now, we should avoid using a distance node to position this circle, since we want to use its coordinates for some effects later. After subtracting to move it, we can once again use a compare node to get the general proportions. Now comes one of my favorite parts, these radial dots. Like I mentioned earlier, we'll take the coordinates from the large circle and add a gradient texture on that position. To get this effect, we'll have to set it from linear to radial and plug the factor output into a math node. Now we'll multiply it by a single value. The greater the magnitude of this value, the more dots we'll end up getting. And after multiplying by a value greater than 1, we can use our fraction operation. This divides our gradient into segments, but that wouldn't help us make circular dots. To make a smooth gradient instead of a jagged one, we need to subtract by a value of 0.5 and then square this output. After using a power of 2, the negatives flip, After using a power of 2, the negatives flip and we get a smooth transition. But as you can tell, this looks really gray and it isn't a value of 1. We need to multiply it by 4 to get white. Here's a quick visual explanation if that helps. These operations are actually pretty simple. The hardest part is usually problem solving. Now, let's move on to the other half of our radial dots. We'll take our length value with the same coordinates the gradient texture used. We'll subtract by around 0.5 and square this output. Now we can multiply by a large number to remove this shallow falloff. You could also use a map range node for this. And that's about it. We now have the 2 components we need for this effect. All we need to do now is add them together and tweak their proportions. Once they are added, we have this beautiful ring of dots. These rings will probably need tweaking since we want them to be circular and not elliptical. We can change their thickness and get some cool effects by multiplying these gradients. And we can change the number of dots by increasing this multiply value. I duplicated this less than node at the end to make rings of these dots. Switching it to compare to get these rings and making a special mix factor between them, we get a really cool effect. This mask is made by flooring a gradient and using a less than node to reveal the dots. Here's the final product for the dissolving dots. To recap, this is done really simply by mixing between this image and this image, using this as a mix factor. Once these things all come together, I tweak the timing to have one ring appear at a time. With the main features of the UI completed, there's only one thing left to add. We need to implement a little symbol animation. The icon I used here is fully procedural. I made it using this node group here. This was made in a separate project I was working on, so it was easy for me to copy these nodes into this animation project. If you want to make some yourself, you could use the same Rain World image I used to get some nice symbols. Both of these symbols are really simple. They're just a handful of rectangles positioned in a specific way. But let's get right into the process of making the animation. First, I made sure to align the icon within the large circle. Then, I duplicated the compare node from the large circle and switched it to a less than. I added the value to the epsilon to get a perfect outline of the ring. After that, we can multiply the symbol with the ring so it only appears when it's within this boundary. Show that. Now we can animate it to shift downward over time. And because we multiplied it, it will become invisible once it's outside of this ring. We'll repeat this process for the other icon, but start it above the ring. It will be invisible until we shift it down just like this, making it seem kind of like a slot machine. And with that, we're pretty much done. In my case, I actually went a bit further and added a couple small details, like, for example, the rings popping as they're filled in with the circles. I can control this effect with a map range node, and I can control the timing with a subtract node. I also made the rings of dots expand right before they disappear. And that's about all we need to make an animation of Rain World's user interface. Since you've made it this far, you should remember that liking helps a ton. I had a lot of fun making this video, and I hope you had fun seeing where I get inspiration and my thought process for implementing shader ideas. Outside of gaming, another source of inspiration is the comments section. Let me know if you want to see a specific video about your favorite shader, or try to prompt a fun challenge. Time to hibernate in real life until the next video. At 1K subscribers, I will delete the default cube.